Hello, welcome to first episode of JDE Crafted. So I'm going to be making a Timascus and brass ring for myself. So got this Timascus off of a seller I found on Instagram who had some pretty good prices. I cleaned it up here just a little bit. It had, you can see this rough turned finish it had when I got it. Cleaned it up here a bit and tried to see what kind of color I can get out of it. And it looks like it's three different materials there. You can see that we've got kind of like a deep blue, a lighter blue, and then kind of orange in there. Three different, and here on the top it has a little bit of purple as the middle color there. So it's some quite nice stuff. And so I'm going to put this on the outside and kind of do like a random ground finish for that, and then just some standard old I think it's 360 brass for the inside of the ring. I'm just gonna put like a nice beveled kind of comfort fit with a mirror polish on there. So I think those two should contrast quite nicely. The nice gold of this brass when it's polished up, and then this titanium. I do not know the alloys of the titanium that are used in this. That's kind of the, I guess, the drawback of buying it from somebody off of Instagram from China. Took a while to ship here, but it's definitely Timascus. It heat anodizes and acts like titanium when you cut it, so don't really have much worries with that there. But yep, so now I've got to figure out what ring size I am and make a CAD design here. So let's go on to that. So I did a little fiddling here with this ring tester, and it looks like my ring finger here works pretty good on 8. 8.5 seems to be a little bit sloppy. It might fall off my finger. And the tricky thing with ring sizes is that they are it's a little bit relative to the thickness of it. You know, like if it was this diameter but it was this long, I really couldn't get it over my finger. So a little bit has to do with the geometry going from side to side to get it over your finger, because your finger's not a perfect cylinder. So I usually try to bias on a little bit of a more firm fit when I'm making a ring for somebody, and then I will just put a heavy bevel on the inside of the ring. But so that's what size I think I'm going to use there. Okay, so I went and grabbed my dad's ring here that I had made for him a while back. This one's made out of some stainless steel Damascus and copper for the inside. It's gotten a little bit of wear on it, but still is quite a neat looking ring. And so I was going to kind of go off of the proportions of this because I liked this. This is a nice balance between being thick and kind of feeling like it's substantial, but also being comfortable on your hand. As my dad's been wearing it for a while and he really likes the fit on it. So if we measure it this way, I'm getting, I just round that off to about 300 thousandths for the CAD model on mine. Do about 300 there. And then somewhere in the range of 100 thousandths there for the total thickness. And I'm actually probably going to model this so that it's 125 thousandths. Just so I have plenty of room to take off material. As you can see, I've done some hand faceting on here, and that just gives it just a little bit more character than a normal ring. I don't know, I'm kind of bored of seeing nice rings with just flat edges. It's pretty low effort to machine, and this gives it a little bit more of character, I think. So I'm gonna try that. So now let's head over to what I got for the CAD design here. Okay, so here's the CAD design that I whipped up for the ring real quick. So the distance between here and here should be about 115 thousandths thickness, which is matching that ring of my dad's that I just showed you. And so that should give me a little bit of room to bevel some off on the inside and bevel some off on the outside there. And then if we go under here, under manufacturer, we can see that I've imported the stock size and I've just made it the exact thickness of the ring. Put the 0 right there, dead center. And then I have an adaptive clearing toolpath, which is taking off 20 thousandths for each pass on here for the axial load, and then it's a 3-flute end mill. I've never done titanium before, so I'm playing it a little bit safe and doing 100,000 step downs with that 20,000 step to cut at about 4,000 RPM, and I think that comes out to somewhere in like 20 inches a minute kind of territory. So I think that should be playing it safe enough, and then I'm going to be using some alcohol to be doing for the coolant on that. Just misted isopropyl alcohol. And then we've just got finishing pass here. And I'm just going right to the final diameter. It doesn't matter a terrible amount where I get that to. I'm just going to make the brass to fit whatever this final diameter happens to be. Okay, so let's get that over the machine. Okay, so this is my setup for holding the piece of titanium while we're going to be machining it here. So I just got a little 3-jaw chuck clamped here in my vise with a little bit of a V-block here. Got that in there nice and square, and everything's all parallel and stuff. I did take a couple of freehand cuts on here to the top to kind of just get that 20 inches a minute at 4,000 RPM that I was talking about for the feed and speeds. That seemed to work decently alright with this end mill in here. So now all we have to do is get our 0 point right there and 0 off the tool. And then we can get going here. So we'll do that real quick. Okay, so I did stop it there momentarily. I saw those chips building up on there. Didn't want that to fly off, so I stopped it, and I'm increasing the blowing pressure on this nozzle to help clear those chips out of there. And now let's go again. Okay, so that looks like it went well here, so I'll take it out. Okay, so here's the product right off the machine. We'll give this just a quick little measure to see where we're at. Get these, make sure we're zeroed out real good. It's supposed to be 300 in this direction. About thousandths, 5/10 off that way. No, you're not really supposed to read tenths with calipers, but if you tighten it up and you get it all nice and straight and you have a good caliper, you can kind of get within that range decently reliably. Okay, so that's good there. And for this inside diameter here, we have 820, 824, 823. So I'm going to make the brass piece, let's say, at 822.5. That's what I'll make this out of. And then we'll heat this up, and then we'll put this in some cold water and press fit them together, so they should be locked together, and then we'll go to the next step there. Okay, so I took a facing cut, and then I took a cut off of this, and so we're going to take the dial here and set it at 0, and then measure what we cut here. And so we're about at 968 thousandths there. Okay, so now we're doing the final pass. It's going to be a pass of about, I think, 6 thousandths. So it should still have a little bit of a load that'll work in our favor here. Okay, so I have the brass sitting here in some ice cold water, kind of getting cold, and then I have the piece of titanium here and some vice grips, and got this ready so I can press them together. But first I wanted to show you, there's kind of a fun little aspect of when you're working with titanium, is that the chips are actually quite flammable, so this can be dangerous. And that's why I used isopropyl alcohol in there to cool it down real quick. I know it could be a little bit of fire hazard, but it's fine in this small little bit of batch, and I'm not letting chips build up. So I've got a little pile here, and I'll bring you over and I'll show you what that looks like when we light it on fire. Okay, so I'm starting off a little bit dark here. There's a nice pile of titanium there. It's going to get very bright, so I thought I'd lower down the exposure so that it looks better in the middle of the explosion. So let's start up here. Okay, and this is post the reaction. You can see here it's quite cool to the touch afterwards, and it kind of makes just a little pile of the oxides of all of it, and have a bunch of different colors in there. But it's a pretty fast acting reaction, and it's quite bright. And you can actually see there's still a little bit left here, and this will give you an idea of how bright it is. If I lock the ISO. See, it does. That's not much of an explosion like the last one, but it does burn quite bright. It's kind of cool. Okay, so I got my dad helping me here, so we're going to heat this up and push this together. Yep. Okay, so I have this pressed in there. You just saw that. And so now I'm just going to cut it off right here in that little gap, cut the brass off, and then I'll re-chuck it up in the mill and cut the inside out and then cut it off of here. Okay, so I made a similar program to cut out the inside of that hole there, and now we're gonna hit go, see what happens. Sorry it's a little loud, my antique air compressor is running here, but let's take this out and see what it looks like. Focus, there we go. So, looks pretty dang good there. Did a nice finish there on the inside, and looks like it got down to the titanium, which is good. And now let's put this in the lathe and part it off. I'm gonna shorten this up here to give us a little bit better rigidity, since we don't have to cut all the way through like we did with the brass. There we go. That was decently successful. Took a little bit of fiddling. Now let's take this out of here, see what we got. Okay, so this is what we're looking at here, right out of the lathe. You can see it's a little rough working, but that piece of brass is definitely in there. So that's nice and tight. So now it is all down to hand finishing. So I might take it to the lathe to get a majority of the bevel on this brass here on both sides, and then might put just a slight bit of a bevel on here as well, and then it's going to be over to the belt sander. But looks like I'm getting some pretty good color there. I actually I know that titanium has two different phases of color when you're doing it with when you're anodizing it, like with electricity, and I've done that before. But I didn't know that with heat you can kind of get up into these green colors. So I think what happened is this got up to about kind of like gray or like white with the blowtorch, and I think when that cooled down it kind of turned into something green there. So I might have to, when I heat anodize this at the end, I might have to see if I can get up to that temperature there. But yep, so let's hop back over to the lathe here and see if we can't clean this up a little bit. Here we have something that's just roughly similar there on each side, and it is looking like a pretty chunky ring, but that should be changed here in a bit once we start to do some grinding on this other part here. But yeah, so looks like it fits on there. Nice, got about the same size for each hand. Then we'll get that nice and rounded over with a little bit of a Dremel tool here. So here's with the faceting all done on the ring here. Got the inside all beveled and polished there. So you can see I got a nice uniformly random finish on the outside there. Has a lot of character to it. And I did it with 220 grit sandpaper, so the oxidization should get a little bit inside of the valleys of the scratches and theoretically hold in there a little bit better than if it was like just, a mere polish and then I oxidized it. So now it's time to heat it up with a torch and see what kind of colors we can get out of this. Okay, so we had a little bit of a fail there. So what happened is that the brass came out of the inside of the titanium because I was heating them both up. I guess I didn't think about that before I ran into it. I'd made these press fit things before, but I haven't heated it up afterwards. And so what happened was it just normalized the metal, and there wasn't any tension in between them because brass is kind of weird if you've ever tried to melt it. It kind of, I don't really know how to explain it. It melts in a confusing way. So this started to get into that kind of blobby-ish stage, and then it came out. So all we got to do is make a new inner one of these, which shouldn't be too hard, but we'll get the coloration of this first. And so I don't really care for how this came out. So we're going to put it in some hydrofluoric acid and get that oxidization layer off of there. This might be slightly troubling because I did try on my blank here to see what would happen if I did electric anodizing. And as you can see, it started to erode one of the metals, and I had it on the correct side of the anodizing, so it shouldn't have been stripping away any of the material, but it seems to have done that. So it doesn't take to electric analyzing very well, and it also has a little bit of like a crystal structure on the side of it. And I've seen some people have crystallized titanium for sale, like on Etsy and stuff like that. And I think really all they do is they get this up to its transitioning temperature right before it like turns into a liquid, but it's still a solid, and then they let it sit there, and then the titanium crystals start growing out of it and just aligning themselves as it's close to that point. Whoever made this must have done something similar to that before they sent it out to me. So when I put this ring in the when I put this ring in the acid, it's most likely going to show up those weird patterns and stuff. But let's go over there and do that real quick. Okay, so I've got some hydrofluoric acid here, and I actually just did a little bit of a cleanup pass here on the titanium, just to throw it in and see if that crystal structure I was telling you about pops back up on there. So I'll put that in and drop the ring in there. There we go. As you can see, it's got this kind of hard to get the light right here. It's very weird kind of crystal structure to it, and had something to do with the way they heated this thing up. It might actually make for some interesting heat anodizing. Just gives it a little bit more character there. So here's that piece out of the acid there, and you can see it's got a lot of weird looking patterns on it. Okay, so I've come up with a little bit of a different way of heating this up that should lessen the heat transfer, thus speeding the process up. When I was doing it on that mandrel, I was dumping most of the heat into the mandrel. So this, just put a little slot in this scrap chunk of steel here, and the ring just sits in that groove and rotates on low speed so that it only has a slight bit of contact with that. So most of the heat should be going into the ring instead of being transferred into what it was being held on. So this should speed things up a little bit. So let's see if we can't color it here, and then we can go and measure it. Okay, so this isn't getting nearly as colorful as I would have liked it to before. can see here, it's just kind of bluish looking, none of those different nice red colors in there. So what I'm actually going to do is I'm going to try to take this over to the buffing wheel and see if buffing it up and then trying this process does anything different. Okay, let's give this thing a quick buff and see what happens. Okay, so back over here at the heating station, you can see it's pretty dang polished looking here. Let's see if this changes anything. First I'm going to take in this is a little bit of alcohol, and just if there's any little bit of residual buffing compound, I could take it off. And I know technically there's some oil from my hands that'll interfere with it, but we're not looking for absolute perfection, so we can just be real careful with it here. Try not to touch it, and just put it back on and do this so it doesn't go rolling anywhere. And let's give it another go. Now the trick is for press fitting it. We can't heat it up to press fit it, so we're going to have to do a little bit of just like, a dry press fit with it, which is going to be fine. So I'm thinking of just getting a real good measurement off of this and then doing it about 1 thou 5/10 oversized on the brass piece, and then just press fit that in there, and then we'll have to find a nice secure way to hold this while we're doing the rest of the stuff. So here's it out of the mixture there, and you can see gave it quite interesting look. This lighting isn't the best, but it's kind of like a weird purpley blue with some yellow highlights. It's not maybe as defined as I'd like it to be, but it's quite a different looking color. So I think I'll stick with this, and it seems to like change as you switch the light on it. I'll see if I can't get it in some better lighting here to give you a better example of what it looks like. Okay, so we got the two different pieces made out here. I made this chunk out of brass and then this titanium ring. Okay, so I was pointing at in the last shot, there's still a little bit of that edge there from when I pressed that in, and so we're just gonna sand that out here. Alright, so here's the final product we got here. I think it turned out pretty good, even though with a couple ups and downs along the way. It's kind of hard to make the colors of the Timascus show up on camera due to the nature of it actually not being a physical color in the sense of like being a pigment. It's a refracted light that makes the colors coming off of titanium, because it's actually essentially when you heat anodize it, you make oxidization layer, which is clear, and then that varies in depth depending on how long you heat it, and depending on the depth of that layer, light will hit and bounce around in there and refract off at different angles. But the thing looks pretty dang neat. I'd say it was a success. Even with that little bit of a failure you had, actually kind of turned out good, because the first one I'd made a little bit too big for my hand, so got a chance to, hack off, I don't know, it was like 15 thousandths or something like that to get it a little bit closer, and now it's a nice snug fit on whichever hand I decide to wear it on. But yeah, I don't think that turned out half bad at all. And got that nice perfect mirror you can see in there. Just dead perfect. Brass just works out real nice with a good polish. And I did notice that even the titanium, if I give it just the slightest bit of a buffing, seems to bring out just a little bit more color. I don't know if that might just be due to it having got dirty during the process, but looks pretty nice. But thanks for watching. I'm gonna throw up a couple pictures of it, all nicely done, so you can see its full glory. Thanks for tuning in. I'll see you next time.